Hey everybody, I wanted to make sure that I actually did an example lab to give you a guide on how to do the homework. So you're going to have different numbers here. I made up some numbers, and to be honest, I made them work out so that data and numbers will work out to be very convenient and nice for the sake of this exercise. But the physics involved is going to be very much the same as we work through the math here. So what I'm saying is that I'm going to roll my hypothetical buggy forward, and these are the times and the positions that it crosses at those times. And so I'm going to go ahead and actually plot these points and do a line and draw a line through the points. So at 0.75 seconds, I'm going to be at 50, which is exactly halfway up. And then at 1.5 seconds, I'm going to be at 100, so right here. And then at 2.25 seconds, I'll be at 150. And then at 3 seconds, I'm going to be at 200 centimeters. And when you draw the line, you don't want to play connect the dots. What we want to do is simply try to fit, starting at the origin, send the best line that we can through the points, more or less like this. Now what we're going to do is use this line to actually calculate a few things that we need. So we want to get the slope of the line. So with this we can actually pick. Now I don't actually pick 2 points on the line. I pick 2 squares that are crossed. So for example, I could actually take, for the slope, I could take this square here, and then I see that there's another square that's crossed here. So this is at 1.5, and that's at 100. And this is at 3 seconds, and that's at 200. And that's actually what I'm going to use to get my slope. So my slope is going to be 200 minus 100 over 3 minus 1.5, which is going to be 100 divided by 1.5. And when I actually work that out, that's going to be quite a big number, actually. So I'm getting 66.7 centimeters per second. How am I getting the units? Because the unit of my slope, it turns out, is the units of my rise divided by the units of my run, centimeters per second. And what the slope actually tells us in real life is the speed of the buggy. And what the intercept tells us in real life, so the y-intercept is here, that actually tells us the starting point or the initial position. Now the equation of the line is going to be y is mx plus b. So y is going to stay as y. The slope is going to be 66.7 times x plus 0. Now what the y tells us in real life is the position on the ruler. And what the x tells us in real life is the time that has passed. So this is really an equation of the buggy as it moves along the ruler. So that's really it for your homework, and I hope this is useful. We're actually going to discuss this in class and use this as the basis of the physics that we do over the next few days.